Okay. So the question is sine theta is given as minus of half and tan theta is given as 1 by root 3. So here we can observe one thing very clearly, that sine is negative and tan is positive, and we have to find out the quadrant. So instead of finding out exact values, from here we can understand that if a trigonometric ratio is negative and another one is positive, then definitely it is not the first quadrant, because in the first quadrant all the trigonometric ratios are positive. And where tan is positive, other than the first quadrant, do anyone know? Other than the first quadrant where tan is positive? It is the third quadrant. So C will be your answer. Is this clear?
Yes, sir.
Yes. This was a professor question of 2019, first paper. Let's go ahead. Here's the next question. Sin theta plus cos theta is given as equal to something, and we have to find out cos theta minus sin theta. So from here, let's square on both sides. So a plus b whole square becomes a square plus b square plus 2ab equal to square of this. Square root of 2 becomes 2. Cos theta becomes 2 cos square theta. Okay. So what we have to find out? Cos theta minus sin theta. Okay. We know sin square theta plus cos square theta is what? 1. And we know what is this? 1 plus 2 sin theta cos theta. This is actually sin 2 theta. This is 2 cos square theta. Let's bring 1 onto the right hand side. Sin 2 theta is equals to 2 cos square theta minus 1. Do you remember what is 2 cos square theta minus 1? What is the formula of cos 2 theta in terms of cos theta? That is precisely this. So this is cos 2 theta. Sin 2 theta is equals to cos 2 theta. We know sin 2 theta can be written in the format of, when first we know from observation that sine and cos are equal on when the angles are 45 degrees, right? Other than this, we can also apply one more method to find out the angle. That sine can be written in the form of cos by cos 90 minus 2 theta is equals to cos 2 theta. Now angles has to be equal. Pi by 2 is equals to 2 plus 2, 4 theta, which says that pi by 8 is our theta. Okay. Pi by 8 is what? 180 by 8, right? 180 by 8 becomes 90 by 4, 45 by 2. So the angle is 45 by 2 degrees, 22.5 degrees. What we have to find out? Cos theta minus sin theta. Okay. So, other than this, we can also apply one more analogy here. One more thing is that can be applied. One is that if we know the value of 22.5 degrees, we'll be able to solve from here. Other than this, there is also another method. That method is sin 2 theta is equals to cos 2 theta. So what we can write here is Sine 2 theta. Cos 2 theta can be written as cos square theta minus sine square of theta. A square minus b square is equals to a plus b into a minus of b. What we have to find out? Cos theta minus sine theta. This is what we have to find out. We know the value of this. This is actually root 2 of cos theta. Okay. So what we will do, we'll simply bring onto the first, we know the value of this. So let's first bring this to the left hand side by dividing it. Sine 2 theta can be written as 2 sine theta cos theta divided by cos theta plus sine theta is equals to cos theta minus of sine theta. We know the cos theta plus sine theta's value is square root of 2 cos theta. So cos theta cancels. 2 can be written as square root of 2's whole square. 2 can be written as square root of 2 into square root of 2. So 1 square root cancels. What is left on the left hand side is square root of 2 sine theta. Cos theta minus sine theta is equals to square root of 2 sine theta. So without even knowing the value of 22.5 degrees for cos and sine, we are able to solve this question because of because of our observation and the use of formula. So which option is correct? C option is the correct answer. Are there any questions, doubts, understanding this?
No doubt, sir.
Okay, then let's solve the other question. Given is P is equals to cosec theta minus cot theta is equals to, okay, and Q is equals to cosec theta plus cot theta inverse. Okay. We know one thing for sure, that cosec square theta minus cot square theta is equals to 1. This is the property from our childhood that we have learned in class 10th. So from here we also concluded that cos theta minus cot theta into a square minus b square is equals to a plus b into a minus b. And hence we can write it as like this. This is given as equal to P. 1 by cosec, like cosec theta plus cot theta inverse. This is inverse. So this is Q, which is our option number B. Clear? This is how easy it is. Any doubts? Should I repeat?
No, sir.
Let's move ahead then. 1 plus tan alpha tan beta whole square plus tan alpha. Let me increase the size of question. 1 plus tan alpha into tan beta whole square plus tan alpha minus tan beta whole square minus sec square alpha into sec square beta is equals to, that is, we need to simplify it. See, here alpha, beta are angles. Alpha, beta are angles. In the options, there are numbers. So it means that this is going to give us some number regardless of whatever angle is inputted here. So for our convenience, we can let any angle for alpha and any angle of beta. Why not considering the same angle? Okay, so we'll assume a same value for alpha and same value for beta, and we'll assume such a value that we'll be able to solve for. If we will assume like 0 degrees, then sec of 0, and the sec of 0 will not be viable for us to find out. Like what will be the sec of 0? What will be the tan of 0? Sec of 0 is 1 by cos 0. So that means 1 by 1. Okay, we can also assume it as equals to 0 degrees. Okay, so 1 plus tan alpha, which is 0 into 0, okay, whole square plus tan alpha, this is 0, 0 minus 0, whole square minus sec square alpha is 1 by cos square alpha, 1 by cos 0, that is 1. So this is basically 1. So 1 plus 0 minus 1, which will give us 0. First option is the correct answer. We have used assumption method here. And this method will definitely work for you and save a lot of time for you. What is this? What is this? In which world we have come? And yes. So this is how we can solve questions easily by assuming. How we can assume? By observing the question and the options and what is being asked in the question. Okay. Are there any doubts?
No, sir.
You could also have assumed alpha and beta is equals to 45 degrees. Then also the question can be solved. Without assuming also the question can be solved, but it will be a strenuous thing to do. Do you want me to solve using long method for now for explanation?
Yes, sir.
So let 1 plus first let me paste it. So let's expand 1 plus a square plus b square. So alpha into tan square beta plus 2ab to tan alpha tan of beta plus tan alpha minus tan beta whole square, a minus b whole square. So a square plus b square minus 2ab. Okay. Minus sec square alpha sec square beta. This is just we have expanded the equation, the algebraic expressions. Not actually equation, this is an expression because it's not equating to anything. It only have one hand side. So here we can see 2 tan alpha minus 2 tan alpha beta cancels each other. Okay. Now what's left? We'll solve with what's left. So we'll take common in this term and this term. What we can take common is tan square alpha. Okay. So after taking tan square alpha common, what is left in this term is tan square beta plus what is left here is nothing plus tan square of beta. Okay. 1 plus, we know one thing. Let's rearrange them. I've done nothing except rearranging, writing this term in the last, writing this term in the first. So if we consider these two terms, this is a one term, this is another term. What is common here? 1 plus tan square of beta and 1 plus tan square of alpha. This is common here. And also one more thing that we are missing out is minus of sec square alpha into sec square of beta minus of sec square of alpha sec square of beta. Now, do you remember sec square theta minus tan square theta. This is the identity. Minus tan square theta is equals to 1. So maybe write it as that sec square theta is equals to 1 plus tan square of theta. Okay. So 1 plus tan square of theta will be sec square theta. So 1 plus tan square beta will be sec square beta. 1 plus tan square alpha will be sec square alpha minus sec square alpha, sec square beta. This term cancels this term. The answer comes out as 0. So option number A becomes correct option. Is this clear? Are there any questions?
No, sir.
So this is like in 1, 2, 3, 4, approximately 5, 6 steps you are solving this question. If you have just observed one fact that alpha and beta are variables which are not depending on the outcome, so you could have just solved it using assuming any angle for alpha and beta. So this is how things become easy. क्या है ये? Let's check. Oh, calcium. Oh, nice. So I do remember this. First element is what? Hydrogen. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and then comes calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. आगे नहीं आता. Gallium, germanium, arsen. Anyways, let's focus on maths. Maths is more fun, right? Do you agree maths is more fun? No? So we solved 235 question. 234th question is here in front of our screens. 10 crore. So, given that sine 2 theta is equals to cos 3 theta, theta's domain is given, important, then what is sine theta equal to? Answer is given of this. From here, I can make out, and we can make out, we learn the formula that theta is somewhat 18 or 36 degree like this. So sine 2 theta is equals to cos 3 theta. We know when they are equal. First, let's convert sine into cos by writing this cos pi by 2 minus 2 theta is equals to cos 3 theta. Cos cancels. Not every time, but in the case of first quadrant, we can cancel them. So we know theta is lying in somewhat in the first quadrant also. So pi by 2 becomes equals to 3 theta plus 2 theta, 5 theta. And theta comes out as pi by 10. Pi is 180 degrees by 10 becomes 18 degrees. Nice. Our guess was right. So what we have to find out actually is sine of 18 degrees. We know the value of sine of 18 degrees. That is root 5 minus 1 divided by 4. Are there any questions? No questions?
No, sir.
It's easy. Just be like attentive in the class. You'll be able to understand these questions if you have learned the formula. Otherwise, Ram Bharose. You're not going to understand anything if you don't remember formulas and values that we have learned in a previous class. I hope you have learned them all because you all are good students. Coming to the next question, what is the value of cos of 46 degrees, 47, 48, 49, 50, and the value is increasing till 135 degrees. So from 46 degree, then 47 degrees, then 48 degrees, and going till cos of 135 degrees. Okay, so we are aware that if we need to find out the product, we are aware that cos of 90-degree value will also be available here. Yes or no? Yes or no? Cos of 90 will be there or not in the product? Yes, it will be here. What is the value of cos of 90 degrees? Yes, please repeat.
0, sir.
Yes. And what will be the outcome of any product if one of the term is 0?
Everything will be 0.
Nice. So B is the correct answer. Clear?
Yes, sir.
Simple question based on observation. Let's go to the next question. We have to find out the value of tan 75 degrees plus cot 75 degrees. We are aware about the values of 15 degrees. Yes. Tan of 15 degrees is what? 2 minus root 3. So tan of 15 degrees is equivalent to cot of 90 minus 15 degrees, which is what? Which is cot of 75 degrees. To find out tan 75, we'll just write 1 by cot 75 degrees, which is 2 minus root 3. So these are two values. Let's add them both. So now adding them, 2 minus root 3 plus 1 by 2 minus root 3. LCM is root 3. 2 minus root 3 is whole square. 4 plus a square plus b square. Root 3 square is 3 only minus 2ab plus 1. So 4 plus 3 plus 1 becomes 8 minus 4 root 3 divided by 2 minus root 3. So let's take 4 common from the numerator divided by 2 minus root 3. This cancel this. The answer is 4. Clear?
Yes, sir.
Easy. Easy peasy cheesy. Next question. Cosine of A is 3 by 4. Sine of half angle and thrice of half angle. What we need to find out this. So we have studied in the formulas that 2 of sine of A into sine of B is equal to what? Cosine of A minus B minus of cosine of A plus B. Is that right or wrong? A. Come on. Do you remember it now or not? Here we have the multiple of 2. So instead of it is A half. And the 2 is also not there. So we'll bring the 2 on the left hand side. So let's bring the 2. So it will go in the denominator. And instead of A, we have A by 2. Instead of B, we have 3A by 2. Nice, nice, nice. So A used to be bigger angle. So let's take A as 3 by 2 and B as A by 2. There's no difference in them. Okay, okay. Now let's sine of 3A by 2 multiplied with sine of A by 2 is equals to cosine of 3A by 2 minus A by 2. 2 as the LCM. 3A minus 2A becomes 2A minus cosine of 2 LCM. 3A plus A becomes 4A divided by 2. 2 cancels 2. 2 cancels 4 by 2 here. What is left? Cosine of A minus cosine of 2A divided by 2. This is what is left. Now, we are aware about the value of cosine of A. It is given to us. And we know cosine of 2A can be written in the form of cosine with this formula. Okay, let's bring the let's bring this to the next page. This can be written as cosine of A minus 2 of cos square A minus becomes plus 1 divided by 2. Cos of A was 3 by 4. Cos of A was 3 by 4. Okay, 3 by 4 minus 2 into 3 by 4 whole square. So 9 by 16 plus 1 divided by 2. 2 cancels 16 by 8. 2. 8 is the LCM. So 3 to the 6 minus 9 plus 8. 8 to the big 8 into 2. 6 minus 9 minus of 3 plus 8, 5. So answer is 5 by 16. Answer is 5 by 16. If there are any questions you may ask. So we have just like observed that this sine of A by 2 and sine of 3A by 2 are in multiply. And we remembered some formula related to that. We modified that formula for our convenience and used it for finding our answer. Clear? And actually telling, I myself didn't know how this question will be solved when I pasted this question on the screen. But I just like things just went by observation. I guessed, I had an intuition just by looking at the problem statement that this formula can be used. And why it was so? Because I by heart remember these formula, and that's why things went step by step. Okay. Are there any questions?
No, sir.
Are there any better method that we can use to find out this? So actually, like there are methods, but there are more tedious than this. Like when we consider cosine of A is equals to 3 by 4, we can write cosine of A is equals to 2 is equals to 1 minus of 2 sine square of A by 2. From there, we can find out the value of sine of A by 2. After finding the value of sine of A by 2, we'll find out the value of sine 3A by 2 by using the formula of sine 3 theta. Sine 3 theta is formula is what? 3 sine theta minus 4 sine cube theta. So that will be even more tedious than this. So instead of that, we have used this formula. So that's a better method that we have used. Okay. Next question. Shall we move ahead to the next?
Yes, sir.
Sprint question. Tan theta is equal to the is given like this. Tan phi is given like this. This is phi. What is the value of theta plus phi? This is asked. Okay. So tan theta is half. Tan phi is 1/3. Okay. Okay. So we are aware that tan theta plus phi, its formula will be given as tan theta plus tan phi divided by 1 minus tan theta into tan of phi. Tan theta is half, tan phi is 1/3, 1 minus 1/2 into 1/3. Taking LCM 6 in the numerator, 3 plus 2, 6 in the denominator LCM also, 6 minus 1. So this cancels each other. 5 by 5 becomes 1. It's equals to tan theta plus. So theta plus phi is equals to tan inverse of 1. So as we have not studied inverse trigonometric function, from here you can just tell on which value for what value of theta tan theta will be pi. Like for what value of tan becomes 1. When does tan becomes 1? On 45 degrees, right? So theta plus phi will also be 45 degree. 45 degrees is pi by 4 in radians. C is the correct option. Clear? Any doubt?
No, sir.
No doubts. Just a Is this question clear? No. Is this question clear or no?
Yes, sir.
Clear. Okay, let's move ahead with the next. Is sine alpha plus cos alpha is equals to P. Then what is the value of cos square of 2 alpha equal to? So we are discussing about 2 alpha. So, and also in options, there is P. And alpha is just a variable, and like for some value of alpha, there are some, like alpha is just there mentioned in the question statement, and it is not even defined. So we can assume alpha for any value, like, so tell me, you tell me any value of theta, like that we can take 0, 30, 45, 60, 90. What should we take? What will be the best?
45, sir.
45. Okay, let's take it. Good. So sine of 45, taking alpha as 45 degrees. Sine of pi by 4 plus cos pi by 4 will give us some value. This is 1 by root 2 plus 1 by root 2 is equals to p. That is 2 by root 2 because it's double. Root 2 cancels 2 by root 2. P becomes square root of. What we need to find out? Cos square of 2 alpha. 2 alpha means 2 into 45 becomes 90 degrees, which is actually 0. Cos of 90 is 0. So 0 square is also 0. So we have to put this value of square root of 2 in the options to find out to get 0. So square root P is actually square root of 2. So this is 2. 2 minus 1 is 1. 2 minus 2, 2 minus 2 into 2 is 2 into 0, 0. And this is 2 plus 1, that is 3. So not option B, D, A are not matching, only option number C. So option C becomes our correct answer. Okay. Is the question clear?
Yes, sir.
Okay, then let's move ahead to the next. It is given that cos theta minus alpha is A, cos theta minus beta is B. We need to find out cos of alpha minus beta. So what we need to find out? Cos of alpha minus beta. What we already have, cos of theta minus alpha as A, cosine of theta minus beta as B. If we find out the difference of both of these angles, theta minus alpha minus theta minus beta, then what it comes out to be? This comes out to be theta minus of alpha minus theta plus of beta. That becomes beta minus alpha somewhat, right? And that is opposite of what we need to find out. So instead of assuming this angle as A and this angle as B, instead of finding A minus B, what we have just done, if we find out B minus A, then it will be alpha minus beta. Do you agree? We have assumed theta minus alpha as A, theta minus beta as B. So B minus A becomes alpha minus beta. Is this thing clear?
Yes, sir.
Okay, nice. Now let's take cosine on both sides. So cosine on B minus A is equals to cosine of alpha minus beta. So this is what we need to find out, the right hand side. So cosine of alpha minus beta is equals to cosine of B minus A. We know cosine of B minus A has a formula, which is cosine of B into cosine of A plus sine of B into sine of A. Cosine of B is given as B is what? B cosine of B is this. This is given as B. Cosine of A is given as A. So BA plus sine of B. We don't know value of sine of B. We know the value of cosine of B. So we can write it as 1 minus cosine square of B. What is cosine of B is B square. So similarly, we can write 1 minus B square into 1 minus A square. This is what is the answer of the first question. Note here, note this because there is a minus sign here, even not matching. So option number A becomes her correct. Clear?
Yes, sir.
Here only one thing needed to be observed is that if we take the subtraction of this angle and this angle, this will come out as the required angle that we need to discuss about. Simple, one observation. And in ahead, we need to find out sine square of alpha minus beta and cosine of alpha minus beta. We have already found out cosine of alpha minus beta. Sine square of alpha minus beta. Okay, so this is simply 1 minus cosine square of alpha minus beta plus 2ab. Wait a minute. Let me save the file. See, what we need to find out here, let me go in the next slide. Let's discuss here. What we need to find out here, sine square of alpha minus beta. We know sine square of theta can be written as 1 minus cos square of theta. So cos square of alpha minus beta. I should write beta properly. Plus 2ab cosine of alpha minus beta that we have already found it out, which is ab plus square root of 1 minus a square. Let's write just that only because we have already cosine of alpha minus beta whole square in the expression. So from here, one thing can be observed, which is that cosine of alpha minus beta can be taken common in the second and third term. So let's do the same. So 2ab is left here and minus of cosine of alpha minus beta. Okay. Now we need to substitute cosine of alpha minus beta. This is the only option that we have. Let's do it. Instead of going and doing all of this, let's do one thing which is very easy to do for us, as always, assuming values. So let's assume theta as 90 degrees, alpha as 30 degree, and why not beta as the same? Let's assume beta as the same only. Okay, but then yes, we can do so. Let's assume beta also as 30 degrees. So while assuming, you have to take care of one thing for sure, that in the question statement, you have to have the assumption within the domain, and there should not be any other condition which is not agreeing with our assumption. So everything is in agreement of our assumption because there are no certain conditions given. Okay. So if that is so, theta minus alpha becomes 60 degrees. So A is cosine of 60, which is half. B is cosine of theta minus 30, which is also half. What we need to find out here? 1 plus cosine of alpha minus beta. Cosine of alpha minus beta means alpha and beta are equal. Cosine of alpha minus beta is like cosine of 0 is 1 to 2ab minus cosine. This is also 1. Solving 2ab minus 1 cancels. This becomes equals to 2ab. Okay. 2 into a is what? Half. B is also half. 2 cancels 2. The final answer comes out as half. Great. Let's now find out when half will be coming by solving this question or by solving these options. So in first option, a square plus b square is considered. So a square is what? 1 by, let me erase the line first. A square is 1 by 4 plus 1 by 4, which makes a square is 1 by 4 plus 1 by 4, which is 4, that is 1 by 2. Okay. Option number A is agreeing, and option number A can be a right option, but we have to solve for all the options because we have to eliminate all other options as wrong ones, as wrong options when we are going and using shortcuts. A square minus B square is 1 by 4 minus 1 by 4, that becomes 0. B square minus A square, same kahani. 1 by 4 minus 1 by 4 becomes 0. 1 by 4 minus 1 by 4 becomes 0. D option, minus of 1 into A square, 1 by 4 plus 1 by 4 becomes half, minus of half. This was 1 by 4 minus 1 by 4, 0. Minus of 1 by 4 into 1 by 4, this becomes minus of half. Our correct answer is plus 1 by 2. So option number A becomes the correct answer. Is that clear? Any questions?
No, sir.
Okay, then let's move on. Why didn't we solve with this only? Because this will become very tedious and strenuous for us if we go by this method. Okay. So I guess that we have discussed enough questions of previous of trigonometry chapter. Shall we move ahead to the next chapter, that is inverse trigonometry function? Simple, short chapter. Or do you want me to discuss more questions of trigonometry? Come on, make a choice. Okay, let me do it then. Let's solve the next chapter, okay? So before starting the next chapter, do you guys want a break? So we can have a break for 3 minutes. 3 minutes are enough, right? Hello everyone.
Yes, sir.
3 minutes are enough, or should we take a break for long?
10 minutes is enough.
Kitne minutes?
10 minutes, sir.
10 minutes. Okay. 10 minutes. So the class will continue at 21, 10 hours. Okay. Not exactly 10, but 9, 10 p.m. The class will continue. So inverse trigonometric functions. So we have already discussed in function chapter earlier about invertible functions, right? The function whose inverse can be finded out. So let's say y, if there is like any expression in x, we call it a y, and x as the function of y. So g is a function, f is a function here. These are two functions. So x is g of y. So let me just replace x with g of y. Strange, isn't it? So what actually I have written f of g of y is y. And similarly, we can write it for x also. X is g of f of x. Here, f and g. Now, here f and g, you can see f and g. These functions are called as inverse functions of each other. As inverse functions of each other. So from here, we start discussing about trigonometric functions. Like, let's say sine of x is y. So here, instead of writing, let me write it on the right side. Sine of x is, we are calling y. If we need to find out the angle, the x, it will be given by sine inverse of y. This is inverse trigonometric function. This is inverse trigonometric function. And in this function, the input will be of some value, like real value. And the output, the function will give this. This will be an angle. Either in radian, we can write it in radian or in degrees. So earlier what was happening? This function, this trigonometric function, input was an angle. But the output was some real value. We call the input as domain. Domain of trigonometric function was angle, and the range for trigonometric function was real value. Here, in case of inverse trigonometric function, let me change color for the trigonometric function. Now, this is trigonometric function, and in white, this is inverse trigonometric function. In inverse trigonometric function, the domain is of real values, and the range is in angles. So that's like the inverse, just inverse. Okay. So let's now discuss about domain and range for the inverse trigonometric functions. Let's now discuss the domain and range for the inverse trigonometric functions. So let's move on. And I'm going to write the domain and range for inverse trigonometric functions. Starting from sine inverse, I'll write the domain here and the range here. Earlier also we discussed about the domain and range of trigonometric functions. It is just going to be the opposite of the same that we have discussed earlier. For sine inverse, the domain is -1 to +1. The range is from -π/2 to +π/2. Both of these values are included. Cos inverse, it is the same. Π/2 is 90 degrees. For tan inverse, there is something unique here. All the real numbers are the domain for tan inverse. And the range is the same. For cosec inverse of x, cosec inverse has a domain of -infinity to -1. -1 is included here. And then from +1 to plus of infinity. The values between -1 and +1 are excluded, and the range is the same. -π/2 to π/2, excluding the element 0. For sec inverse, it is the same except the range. Domain is same. In the range, it is from 0 to pi. Minus excluding pi/2 angle. Why pi/2? Because sec of pi/2 is what? Sec of pi/2 is what? Not defined. That's why its range is not defined in this manner. And also for like cos inverse also, it is from 0 to pi. And then left is cot inverse. Again, the domain is real numbers, and 0 to pi here, excluding 0 and pi values. So this is the domain and range of inverse trigonometric function. Are there any doubts in this? In understanding any one of these? No? Let's now move ahead and discuss the properties of inverse trigonometric functions. And these are going to be important. First, simple sine inverse of sine theta is theta. Thing to understand here, the theta should be in the principal domain or principal range, as we call it for the inverse trigonometric function. For cos inverse of cos theta, this will also become theta, given that theta should lie in 0 to pi. Tan inverse of tan theta will also become theta only, given that theta is in its principal domain. Same for every other inverse trigonometric function. Let's start from cosec inverse, cosec theta. It will also become theta. Sec inverse of sec theta will also become theta. Cot inverse of cot theta will also become theta. Here, theta should be in its range, that is excluding 0, the midpoint of the range. You can remember it using this method. The midpoint, that is pi by 2 theta 0 to pi. Pi is 0 and pi are not included in case of cot. Open bracket. These are some properties. Is there any confusion in understanding them? Let me give you an example. That sine inverse of sine pi by 6 can be written as pi by 6 directly. There is no issue in writing like this. No issue. Okay. If it is like the sine inverse of sine 120 degrees, then it will not be equal to 120 degrees. Why? It is not in the range of inverse trigonometric function. So what will we do in this case? We will change sine 120 into something else. So sine 120 can be written as sine of 180 minus 60 degrees. We know in the second quadrant, sine remains positive. So it becomes sine 60. And hence, 60 degrees is in the range of inverse trigonometric function. So answer will come out as 60 degrees, not 120 degrees. Understood the difference? If 120 degrees was out of the range, so that's why we converted it into the range first. And even if there is there is some negative sign with it, we'll take that negative sign out of this. Okay. Any doubts?
No, sir.
Moving ahead to the next properties. This time sine outside. And then sine inverse of x inside. This will also become x given that it is in the domain of x. And similarly, we can write so for all of the trigonometric functions. Cos inverse of x will be as tan of tan inverse of tan inverse of x will be x. Cosec of cosec inverse of x will be x. Sec of sec inverse of x will be x. Cot is left. Cot of cot inverse of x will be x. In their ranges or domain, as we call it, like the range for trigonometric function. In the range, the trigonometric function. Here the range for cosine is -1 to 1. For tan, it is real numbers. For cosec, it is minus infinity to -1 to 1 and then infinity. For sec, also the same. Actually, infinity is never included. real number again. Okay. So you are not supposed to remember them. You just understand them, that how it is written. So simple. Are there any questions? No.
No, sir.
Okay. So let's move ahead. Now these properties are very important because they do not follow a monotonicity like the earlier properties were following. So what if we have to find out sine inverse of minus of x? Then this will be equal to minus of sine inverse of x. Given that x should be in its own domain. For cosine, things are a little different. You have to subtract pi from it. Pi minus cosine of x when x is in its domain. For tan, it is simple. Minus of tan inverse of x belonging to all real numbers. For cosec, it is also simple. Minus of cosec of x, given that x is there in the its domain. एक तो यार I'm getting confused writing these many curves. For sec, things are little unique, like the cos. Given that x is there in its domain. For cot also, things are different. So let me change the color of unique properties with the green color. For cosine inverse also, cosine inverse of x. See, now observe the pattern. For cos, sec, and cot, pi is coming. Other than that, directly the negative sign is used. For cos, sec, and cot. For cos, sec, and cot. Cosine is C, like it is having C in its first letter, and sec and cot are prominently dependent on cos. Why? Sec theta is equals to 1 by cos theta, and cot theta is cosine theta by sine theta. So cot theta is predominantly dependent on cos. This is how you can make a logic, and you can remember that these three are different. Okay, clear? Is there any difficulty in understanding these?
Clear, sir. No, sir.
No. Okay. So let's take an example. Cosine inverse of minus of 1. To find out cosine inverse of minus of 1. Now this is having a minus. So for changing it, pi minus cosine inverse of 1, we can write it like this is what the property says. Okay. When do when do cos becomes 1? It becomes on 0 degrees. So answer comes out as pi. So on cos of pi, we'll get minus of 1. This is what the function is trying to say, which is actually the truth. So hence, this is how we can use the property. Clear? Is this clear or not?
Clear, sir.
Okay. Then let's move ahead with discussion of next properties. We knew that 1 by sine is cosec, 1 by cos is sec, 1 by tan is cot. So in inverse trigonometric form of properties, they have its own unique expression. Sine inverse of 1 by x becomes cosec inverse of x. And every time, whenever like I'm going to write it again and again, x is in the domain. Cosine inverse of 1 by x is equals to sec inverse of x, given that x is in its domain. For 10, things are a little tricky. And wherever things are tricky, definitely the question is going to build up from there only. So tan inverse of 1 by x will become cot inverse of x when x is greater than 0. And when x is negative, tan inverse of 1 by x, then it will become minus of pi plus cot inverse of x. The third one, this is important to understand. When x is becoming negative, x is less than 0 means this is negative. Clear?
Yes, sir.
Is there any doubt? No. Let's take an illustration. Let's take a famous example that it is given to us. Given that sine inverse of x is equals to theta. This is given. Now we need to find out. Now we need to find out the value of theta in terms of cosine inverse, tan inverse, cosec inverse, sec inverse, cot inverse, in all other 5 remaining trigonometric ratios. So from here, first we can, what we'll do, what from here, what we can say that x is equals to sine theta. Okay. And sine of theta is equals to x by 1. So in right angle triangle, if this is the theta, so sine theta is what? Perpendicular upon hypotenuse, right? Perpendicular upon hypotenuse. So this is x and this is 1. Using Pythagoras theorem, we can write it as 1 minus x square. Sine theta is x by 1. So similarly, cos theta is what? Base upon hypotenuse. This is what? Square root of 1 minus x square by 1. Simple. So theta can be written as cosine inverse square root of 1 minus x square. This is one that we wanted to find out. Similarly, tan theta can be written as perpendicular upon base, which is x by 1 minus x square root of 1 minus x square. So theta here can be written as tan inverse of x by square root of 1 minus x square. This is another one thing, another one expression that we wanted to find out. Similarly, we can do the same for cosec and sec. Let us do it only. What is cosec theta? It is basically 1 by sine theta, so it becomes 1 by x. theta becomes cosec inverse of 1 by x. What is sec theta? Sec theta is 1 by cos theta. So, which is actually cos theta was what? Cos theta was square root of 1 minus x square. So, 1 by square root of 1 minus x square. Theta becomes sec inverse of 1 minus square root of 1 minus x square. This is another format that we wanted to find out. Similarly, cot of theta is based upon hypotenuse or 1 by tan theta, which is square root of 1 minus x square by x. Okay, so theta becomes cot inverse of x by square root of, no. Cot inverse of square root of 1 minus x square divided by x. Another expression that we wanted to find out. So this is how we can solve for different sine theta, cos theta by using this right angle triangle illustration. Any doubts so far?
No, sir.
Okay, let's now discuss some more properties. And now this time I'm going to write some formulas for you, which are similar to trigonometric formula. You just have to correlate them. Just have to correlate them. So first, and this time I'm not going to write plus and minus formula differently. I'll just write them single-handedly, like sine inverse of x plus sine inverse of y is equal to, now this time we are not writing x plus y. We are writing sine inverse of x plus sine inverse of y. This will be equal to sine inverse of x into square root of 1 minus y square plus y square root of 1 minus x square. So this is for the plus sign. For sine inverse minus sine inverse of x minus sine inverse of y, this will be sine inverse of x square root of 1 minus y square minus y to square root of 1 minus x square. Is this formula clear? Is there any difficulty in understanding this? Yes or no? Hello?
Yes, sir.
Yeah. Okay. For cosine inverse of x plus cosine inverse, beauty comes first. Cosine inverse of y. This can be written as cosine inverse of x, y minus square root of 1 minus x square into square root of 1 minus y square. For plus, minus, and if there is minus, then there will come plus. Is this clear? Please don't be confused with plus minus sign here. Okay? Any doubts?
No, sir.
Okay. For tan inverse of x plus tan inverse of y, so it will become tan inverse of x plus y divided by 1 minus xy. For minus x minus y divided by 1 plus xy. Okay. Here, this will be defined for all formulas where x and y, the product of x, y, for all product of sy less than 1. This is the situation, this is the condition for this formula to be applicable. If xy is greater than 1. If the product of sy is greater than 1, then tan inverse of x plus tan inverse of y, this will become tan inverse of x plus y in case and xy minus of 1 or plus. Other than this, we can also write in one more method by writing like this: pi minus tan inverse of x plus y divided by 1 minus x for the plus sign. For the minus sign, minus here and plus here. Are there any questions? When the product of x and y exceeds 1, then we have to apply this formula. Okay, when you will start applying these formulas and start thinking for why it is so, then you yourself will come to know that that actually xy is greater than 1. So definitely the value inside here is going to become negative. If this is going to become negative, this minus minus will become positive, and pi plus theta will lie in the third quadrant where tan is positive. This is why this is all has been done. Clear?
Yes, sir.
Okay, let's now discuss about the formulas of double angles. What we discussed earlier, that sine of 2 theta is 2 sine theta into cos theta. Here 2 sine inverse of x is written as sine inverse of 2 into x square root of 1 minus x square. So you will able to make out somewhere that instead of sine theta, we have written somewhere x. Instead of cos theta, we have written somewhere square root of 1 minus x square. Okay. Candidates often get confused with these formula, but you have to have a strong understanding of them by correlating this formula. Earlier, we had lot of formulas for cos 2 theta. This time we'll have lot of formulas for this 2 tan inverse of x. Tan inverse of 2x divided by 1 minus x square, or it's equal to sine inverse of 2x divided by 1 plus x square, equals to cosine inverse of 1 minus x square upon 1 plus x. Remember, here x is somewhat correlating with tan. So tan 2 theta, sorry, 2 tan theta upon 1 minus tan square theta was the formula of tan 2 theta, right? Let me remember you from writing here, by writing here that tan 2 theta was the formula of 2 tan theta divided by 1 minus tan square of theta. Sine 2 theta's formula was 2 tan theta divided by 1 plus tan square of theta. cos 2 theta formulas was 1 minus tan square theta divided by 1 plus tan square theta. Cos 2 theta formula was 2 cos square theta minus of 1 for this, and sin 2 theta was 2 sin theta cos theta. So this is how the game is getting inverse in inverse trigonometric function. Observe this slide for a minute. This is really very important. Most candidates get confused here. Sin 2 theta is equals to 2 sin theta into cos theta, which is now getting manifested in the form of 2 sine inverse of x is equals to sine inverse of 2x into square root of 1 minus x squared. Cosine of 2 theta is equals to 2 cos square of theta minus 1, which is now becoming 2 sine inverse of x is equals to cosine inverse of 2x square minus 1, or 2 tan inverse of x was equal to tan 2 theta was equal to 2 tan theta by 1 minus tan square theta, which is now getting manifested in the format of 2 tan inverse of x is equals to tan inverse of 2x upon 1 minus x square. Sin 2 theta is equals to 2 tan theta upon 1 minus tan square theta, which is now getting manifested itself as 2 tan inverse of x is equal to sin inverse of 2x upon 1 plus x square. Cosine of 2 theta is equals to cosine of 2 theta was equal to 1 minus tan square theta upon 1 plus tan square theta, which is now becoming 2 tan inverse of x is equals to cosine inverse of 1 minus x square upon 1 plus x square. If that is clear, shall we move ahead?
Yes, sir.
Yes. Mathematics is all about patterns, and you have to be good at observing those, solving them rightly. Next comes triangle formulas. Simple. 3 sine inverse of x is equals to sine inverse of 3x minus 4x cube. Sine 3 theta is equals to 3 sine theta minus 4 sine cube theta. 3 cos inverse of x. Similarly, cos inverse of 4x cube minus 3x. This formula is very important. Very important. 3 tan inverse of x is equals to tan inverse of 3x minus x cube divided by 1 minus 3x squared. Tan 3 theta was what? Tan 3 theta was equal to 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta. This is how you can correlate and learn. There are some other important formulas as well. Sum of three angles, if they are given equal as pi by 2 or pi or 3 pi by 2, then we can say that I should write. Then we can say that the relation between these x, y, z will follow this. And for pi, now you need to understand one thing. If in question, if this is given to like something, if sine inverse of x plus sine inverse of y plus sine inverse of z is given as pi by 2, simply do one witty thing, that let, you just let x is equals to y is equals to z. That means that 3 sine inverse of x has become pi by 2 now in the first case. So sine inverse of x has become pi by 2 by 3, that like pi by 6. That is, x is half here. Simple. X, y, z is half, and you can solve the remaining question. So by using assumptions, questions become really easy. So this is not much of high importance, but still if you remember it, it will help you. Let's talk about cosine. So from here itself, we can observe a pattern that sine inverse x can be written as pi by 2 minus cosine inverse of x. Have we discussed about it or no? We haven't. Let me tell you one important property that earlier we used to talk about. Let me write here. Sine inverse of pi by 2 minus x is cos inverse of x. Similarly, sorry. Sine of pi by 2 minus theta is cos theta. Here, pi by 2 minus sine square of inverse of x is cos inverse of x. Pi by 2 minus cot inverse of x is tan inverse of x. Pi by 2 minus sec inverse of x is cosec inverse of x. Similarly, it's similarly to sine of pi by 2 minus theta is equals to cos theta. It is just as same as that. Clear? And or you may also write that sine inverse of x is pi by 2 minus cos inverse of x. And tan inverse of x is pi by 2 minus cot inverse of x. Or we can say sec inverse of x is pi by 2 minus cosec inverse of x. This is important. And one more important property is left, that from here we can consider, from instead of sine inverse of x, we can write pi by 2 minus cosine inverse of x. So this one, let me write it here, that cosine inverse of x plus cosine inverse y plus cosine inverse of z is equals to 3 pi by 2 minus sine inverse of x plus sine inverse of y plus sine inverse of z. One more property is left. Let me complete it. Tan inverse of x plus tan inverse of y plus tan inverse of z is equal to tan inverse of x plus y plus z minus xyz divided by 1 minus xy plus yz plus zx. Last property of this chapter. Clear? Any doubts? Any doubts?
No doubt, sir.
Okay. Thank you then, Jai Hind. Good night.
Thank you, sir.
Thank you, Sir.